Here we are looking at the IK configuration of the nose limbs. If we turn around and look at the right rear leg, we're going to look at the overall configuration of the bones on this leg. If we select the thigh and turn off Use Custom Mesh, we can see that this thigh bone starts up inside the pelvis and comes down where it joins on with the tibia. Turn off Use Custom Mesh and also select the large cannon bone. We can see this is a 3-bone leg, and the ankle is actually this small bone called the flanx prima at the bottom of the leg. The hoof is actually just one toe made up of one bone. So this is a slightly different configuration from quadruped legs in Cat 1. The FK-driven IK system gives us a lot more control over the layout of the bones, and this 3-boned chain, IK chain, is much more flexible and powerful than the configurations in Cat 1. If we turn this character around and look at the left leg and scrub through our animation, we can see that this character is taking some stepping motions. FK-driven IK means that at any point in the animation we can look at the shape of this leg and modify it. Just using keyframing tools, we can grab this leg. We can say that we'd like the thigh to be more tucked up or less tucked up. We could also, if we chose to, completely reverse the shape of the leg throughout this step. But it's the subtle details which we aim to solve here. We can look around, we can find this joint where the tibia joins on with the thigh. We can push that bone in or out. We can push this ankle bone in or out. So the shape of this leg, at any point in our animation, we have complete control over. We can also come down to this flanx bone, and if we rotate this, we can also control the bending between the flanx and the hoof, and the flanx and the large cannon bone. So FK-driven IK gives the artist control over legs where, in the context of quadruped legs, it's very important to get the exact shape of the leg that you're looking for. Now, the front legs, it's also important that at some stages the legs are virtually straight, while in other situations the leg needs to curl up. So a standard IK system would be very hard to control in this context. At the point when the foot's planted, we want the leg to be close to being straight. But as it lifts up, we want the leg to be bent in a very particular way. So we can grab these bones and start rotating around. We can cause more bending to happen in the lower part of the leg, more in the upper part of the leg. If we look at the layout of this leg, we can see we have a large, what would have been the collarbone. It's been animated as the scapula. If we turn off Custom Mesh, we can see the scapular bone. If we select this bone, turn off Custom Mesh, we can now see quite clearly the layout of this front leg's bones. The scapula, of course, has just been keyframed simply, so there are a selection of keyframes on that, and it is not included in the IK system, but it is also very useful for controlling the IK system. So the first bone, which is actually solved using IK, is this humerus, and then the radius. So this IK configuration gives the artist a lot of control over the exact shape of the leg at any point, and is also very easy to use. You can use either position or rotation controls to adjust the shape of the leg, and yes, you can see the control we get here.